Hello everyone. Have you ever asked ChatGPT a question and received a wrong answer with complete confidence? Or wondered how AI can answer questions from company PDFs, internal documents, or newly uploaded files that were never part of its training data? The answer is RAG, Retrieval Augmented Generation. Today, we will understand what RAG is, why it was invented, and then its architecture, embeddings that are used in RAG architecture, vector databases where all the data, like company data, is stored, chunking, searching, re ranking while providing output to the user. Let's first understand the problem. Suppose we ask, what is our company's leave policy? A normal LLM works like this. Question is forwarded to LLM and answer is returned. The model answers from memory, but there are three problems with this model. Problem 1, knowledge cutoff. The model was trained months ago. It doesn't know today's news, latest company policies, newly uploaded documents. Problem 2 is hallucinations. Sometimes AI simply invents information. For example, user asks how many leaves to employee get, and AI just says 25 leaves, but actual policy may say 20 leaves. Problem 3 is private data. Company documents are private. They were never used during training. For example, employee handbook, insurance policy, HR documents, these are not actually used while giving answers to a user's query. Model has never seen them. So, how can AI answer? That's where RAG comes in. RAG stands for, as we already know, Retrieval Augmented Generation. Let's break it down. Retrieval is searching for relevant information. Augmentation is adding retrieved information to the user prompt, the user query that user has asked, and then generating the final answer. Imagine a student without RAG. For a question, answer is searched in student's memory. But with RAG, after receiving question, student opens the book, reads relevant pages, and then answers. Exactly the same thing happens in AI. This is the complete architecture. Here first part is document ingestion. Suppose company has employee handbook, leave policy, travel policy, insurance PDF. These documents are loaded into RAGDB. But there is a challenge. Some PDFs are 200 pages. LLMs cannot search giant documents efficiently. Hence, we need chunking. Chunking means dividing documents into smaller pieces. Suppose PDF contains 100 pages. After chunking, 500 chunks are created as chunk 1, chunk 2, chunk 3 till chunk 500. And chunk 1 contains employees are entitled to 20 annual leaves. Chunk 2 contains, suppose, unused leaves may be carried forward. Chunk 3 contains employees receive medical insurance. Like that, each chunk has different kind of information. Now, why chunking? Because searching small pieces is faster and more accurate. Now, there are different chunking strategies, fixed size chunking or sentence based chunking, that we will cover in a separate video. Then let's move to third step in first part, which is embeddings. And this is the heart of RAG. Many beginners struggle here. Let's simplify. Humans understand meaning, computers understand numbers. We need a way to convert text into numbers. That is called embedding. For example, annual leave policy becomes 0.23, 0.51, 0.89, 0.14, any numbers. Another sentence like vacation policy might become 0.24, a vector. 0.48, 0.87. Our embedding function is applied to each of the content, to each of the chunk, and then this vector is created, which contain all the information in the form of numbers. Now, while converting these text into vectors, because some chunks might contain similar kind of information, so the resulted vector might also be similar. Similar concepts, similar vectors are stored closely. Popular embedding models are OpenAI embeddings, BGE, E5, that also we will cover in a separate video. Now, after data is chunked and embedded, it is stored in vector database. One point to note here is how this vector DB is different from normal database. Normal DB like MySQL, PostgreSQL, Oracle searches keywords, but vector databases searches for meaning. For example, user searches vacation rules. Document contains annual leave policy. Now, keyword search may fail and normal DB might not return anything, but vector search succeeds and data is returned from vector DB. Popular vector databases are Pinecone, Viviate, Milvus. Now, documents are formed into chunks, then embedded using APIs and stored in vector database. Now comes the second part of this architecture. User asks question how many annual leaves are allowed. The flow is question is put into embedded model, then converted into a question vector, and then a vector search is performed. Now database returns chunk 78 and chunk 79. Chunk 78 contains employee received 20 annual leaves and chunk 79 contains unused leaves carry forward. Similarity search finds nearest vectors. For example, here chunk 78 and 79 are returned because they are near and similar. Then comes prompt augmentation. System creates a prompt where context is added to the user query. Here context is employee received 20 annual leaves, unused leaves carry forward, and question is how many annual leaves are allowed. Now the process is called augmentation because the user query is augmented to the context, which is the answer that we have got from our model. Now LLM receives question plus received context and generates employees are entitled to 20 annual leaves annually. The answer is grounded in actual documents, much more reliable. Sometimes retrieval is imperfect. For example, chunk 1, chunk 2, chunk 3, chunk 4, multiple chunks are returned. A re-ranker scores them. Chunk 4 has score 95, chunk 2 has score 90, chunk 1 has score 80. Best chunks are sent to LLM, and this dramatically improves accuracy. We will continue this in another video. Thank you for watching.